Okay, so our first article by Protostar abuses application logic in order to attack the heap. So if you look at this program over here, we have two pointers, I1 and I2 name, right here, as you can see, and these are allocated on the heap. And near the end, we see these two string copy functions, which uses those two addresses to store data onto the heap, right? This is a dangerous situation because now an attacker can use this to override the pointers. Because remember that string copy, it does not check for boundaries when it takes input from the user. So using argv1, we can put data into this pointer into this location wherever this is pointing to, and we can override a bunch of information past it, including the pointer I2 name, and we can make that point to the malicious function. And so this basically abuses application logic when we want to conduct a heap attack. And the second one, which is by Wikipedia, abuses the it does not abuse the application logic, but it abuses the heap algorithm itself. So here we see a bunch of string copy functions, and then it frees all of the data on the heap. So in the program, A, B, and C are pointers that point to data on the heap, but the data is also freed using the free function, as I mentioned. When we free the data on the heap using the free function, each chunk of memory contains the address of the next free chunk. This way, the system can identify where the free chunks of memory are allocated. So using a linked list, block A contains the address of block B, and block B contains the address of block C. The free call uses pointers called FD and BK. BK writes to FD, meaning that we can use BK to override FD. So FD is the pointer that contains the address of each chunk here. And once we override that pointer, we can use it to point to our malicious function or malicious code. So when we try to fill the empty chunks on the heap and we unlink the blocks, we unlink them, one of the blocks pointing to the malicious code will be triggered. And the last version of heap attack is by Geeks for Geeks. And in this article, it's basically is pretty simple attack. It basically allocates a bunch of bytes of memory again and again on the heap, and this will cause data corruption, memory leakage, and most likely program crash. And the program will crash because this first main function allocates a bunch of memory on there, and then the second one is it basically tries to allocate a huge amount of memory at once. This will also cause a program crash. And that's pretty much the summary of the three research articles.